7th graders, here's our lesson on 5-7. In 5-7, we're going to be solving equations, and we're going to be reviewing the same process that we did before. It's just a one-step equation. If you have a variable plus a number equals another number. On this side, on the left side, you have the variable and the number. On this side, you just have a number. So if you eliminate or you get rid of this number, that gets the variable by itself, doesn't it? And so we learned before that if you add the opposite, it equals 0. And if you add the opposite to both sides, you keep the equation balanced, and you also solve the equation for the variable. So if we're going to solve this for g, you can add negative 9/10 to this side, that equals 0. So g plus 0 equals g, right? And if you add 9/7 to this side, I'm sorry, negative 9/7, 9/10 I mean, you have to turn this around and do 9/10 minus 7/10 in order to get the answer, right? Why do you have to do 9/10 minus 7/10? Joey.
It's plus negative.
Okay, it's plus negative, so we have to find the difference between the two. And the bottom number, or the amount you're taking away, has a higher absolute value. Notice that 9/10 has a higher absolute value than 7/10. So you have, in order to find the answer 2/10, you have to do 9 take away 7, right? Remember that for absolute value, for adding integers and for adding fractions, you have to do the higher absolute value minus the lower absolute value. And it becomes really important when you're working with mixed numbers. Okay? So, let's look at another example. Let's look at this example. A plus negative 1/8 equals 5/8. In this case, we add 1/8 to both sides. So A plus 0 equals A. And then on this side, 5/8 plus 1/8 is 6/8, or 3/4. How would you check the solution? Chase?
Reverse it.
Yeah, you just reverse it. You put the solution in place of the A in the original equation. So instead of writing A minus 1/8, you write 6/8 minus 1/8 equals positive 5/8. And if it's true, then it checks. Okay? So you'll always, to check it, put the solution into the equation. Okay? Now, let's do one more. And let me show you what happens here. Let's do n plus, let's see, 1 and 3/5 equals 2/7. Let's do that. Okay. Now, what would we do to get rid of to get the variable by itself? We'd add negative 1 and 3/5, right? So that equals n plus 0, which is n. Then on this side, we could add negative 1 and 3/5, which we'd have to use a common denominator. what would that be?
35.
1 and 35. So we multiply by 7, right? Then change this to 35ths. And we multiply by 5, right? Then we'd have to actually do 1 and 21/35 minus 10/35 to get the answer, right? So that's 1 and 11/35. Okay? Now, what if you convert it to a common denominator, but this one is smaller? What if we had, what if when we converted it, we ended up with like 6/35? Then, could we do 10 minus 6 and get 4/35? 1 and 4/35? What's wrong with that? Chase?
Can't minus 6 and 10 go like that way.
You can't, yeah, right. What happens when we turn this around? Let's check this by turning it around and using the biggest absolute value, 1 and 6/35 minus 10/35. Does that work? Is that 1 and 4/35? What would we have to do, Michael?
Turn it around.
No, we can't turn it around because we have to use the bigger absolute value minus the smaller
Make
absolute
it
value.
an improper fraction.
Make it an improper fraction, right? We have to cut up this whole and add 35, right? To make this 41/35. Take away 10/35. What's that? 31/35. Okay, not 1 and 4/35, because the smaller fraction is above. We have to use the bigger absolute value minus the smaller absolute value. Okay? Repeat that. You have to use the bigger absolute value minus the smaller absolute value to find the answer with fractions. Okay? Otherwise, you start looking at this and say, oh, 10 minus 6 is 4, and then 0 minus 1 is 1. So that's negative 1 and 4/35. No. We have to turn it around, and then we'd have to cut up the whole. Okay? You get the wrong answer if you do that this way. Any questions about that? Alright, so we're solving those simple equations simply by adding the opposite to both sides.